Let's talk about the most important starting topic for any science class, and that is some of the math uh, solutions that we might need to do. So in this video, I will talk about dimensional analysis and focus on one of my favorite things that I like to call, which is roadmaps, which sets us up. So just to get some terms clear, I don't know where to start with this. Let's see, the process we want to do when we're looking at some problem in the book is to make sure we understand what the problem is. So sometimes it's really obvious, and I think that's a distinction between, say, a math problem in a math book and a sciencey problem in a chemistry book, is that in a math class it might be very, very obvious what you need to do. I'll give you an equation and it'll say solve for x, whereas in a chemistry problem there could be a whole bunch of information that you have to process. So my thought here is this clarification stuff, that if you're taking a test, actually circle what it is you're trying to figure out, or write the word find off in the margin and then say whatever it is you're trying to find, but really clarify to yourself what it is you need to do. Alright, once you kind of identified what the question is asking, then this roadmap thing is the important part, and that's your strategy of how you're going to do the calculations. From the roadmap, you'll write out a solution, describe that a little more down here, and then we do the calculations, and that process would be both making sure the units work, so canceling units, but also doing the mechanical calculation either, in your head or on your fingers or with a calculator. Alright, so roadmap. A roadmap is a pathway for doing the calculations. In class, depending on when you've watched this video, we might say convert kilometers to feet. So our roadmap might be kilometers to miles to feet, or maybe it'll be kilometers to meters to centimeters to inches to feet. It's important to know that there's not, oftentimes anyway, there's not just one right answer. You could have a couple probable answers, or a couple possible roadmaps, that is. Hopefully that's just one answer. And those roadmaps will differ depending on some stylistic stuff, especially if you're somebody who does a lot of calculations. You might have sort of some favorite go-to conversion factors. But on top of an exam, sort of like down here, you might have listed very specific conversion factors, and you are limited to those, and so a pathway that you might automatically do just isn't available to you. Alright, so again, the roadmap, the pathway for calculations, there's multiple right answers. Usually the steps that you choose in the roadmap are based on either experience, you've done this kind of problem before, or you've looked through the conversion factors given and you see how you connect the pieces together. Important to know, these two here, is that our roadmap does not typically have numeric information. If I had something that was convert 3 kilometers to inches, I wouldn't use the 3 in the kilometers. I just look at the kilometers. Okay, so you're not including the data from the word problem. Additionally, you don't show the conversion factors. And the conversion factors are what let you go from A to B to C, but that's more of an awareness that they exist. And we'll do examples on that. Okay, the solution I would describe as the quote-unquote show your work part of the problem, where you're showing the various terms. And here's where the roadmap comes into play, is that your roadmap is going to be, A goes to B, goes to C, and what you'll end up doing is the ability to go from A to B, say from kilometers to meters, is going to be using a conversion factor. And so what you're going to do is you're just going to substitute in conversion factors for all the arrows that you might have drawn in the roadmap. Very, very important to focus on the units in this, so that as you go from, say again, kilometers to meters, we're somehow canceling kilometers in that first step and converting to meters. So typically our conversion factor would have the first units in the denominator and the second units in the numerator, so that we cancel the original units. And then very important is that we do the dimensional analysis part, is that once we've got everything set up, go through and actually cancel the units as we're supposed to do, and we see that we get the final units that we expected to get back when we said, whatever we said, clarify whatever the problem is, find inches. Did the units give us inches? Yes, good. If they didn't, then something's wrong with the roadmap. And then the very, very last step, almost trivial, is that we do the calculations. Okay, so again, depending on when you watch this video, we've done a couple of examples. I've tried to stress the roadmap part, so hopefully you've got a little bit of experience with that. And here's a couple of quick problems. So what I want you to do, though I'm not watching over your shoulder, at least you don't think I am, is do these two problems. So let's leave you your conversion factors here. One example here, what is the walking speed in meters per second if someone can walk 1 mile in 18 minutes? And then the second one is a textbook problem. This is actually problem 2.100, so chapter 2, problem 100. It's not an answer, that's a problem. And it reads, in Mexico, avocados are 48 pesos per kilogram. What is the cost in cents of an avocado that weighs 0.45 pounds if the exchange rate is 18 pesos to the dollar? So, probably the right thing to do is to pause the video, work both of these out, and then play it again when you're ready to go. So, I'll stop talking for a sec. Okay, I'm back. So, what do we want to do here? Well, what we want to do is that process that was described as above. And again, if you've not paused and tried to work this out on your own, I think it's very important that you do. So, the first thing, and I really like to see this identified, is that we're going to do the roadmap. Oh, I guess that's the second thing. First thing is make sure we understand what it is we're trying to do. So we're starting with, it's not listed as a ratio, but we're starting with two pieces of information, and that is that the distance is 1 mile and the time is 18 minutes, and ultimately we're supposed to get to that same kind of quantity of speed, but now in meters per second. Finish. So my roadmap here needs to reflect that. Now again, this one isn't obvious. I typically don't set up problems quite like this, but it's not unlike one that's in the book. So my speed here, which is going to be distance over time, is going to be miles per minute. And from that I want to get to meters per second. And sometimes what I like to do is say, I'm not really sure how many steps this is, so I'll just sort of do a bunch of arrows, clarify that that's what I'm trying to do. Maybe I see what's going on here, and I can see, oh, okay, I got miles to meters. Do I have that up here? I got miles to feet. I got feet to inches, inches to centimeters, centimeters to meters. Okay, so it's a bunch of steps, but it's doable. Sorry, I didn't have that all shown. But anyway, those units are up there. And then, of course, minutes to seconds is easy. I put it here, but 60 seconds in a minute. Okay, so again, not super trivial, and I should have spread out a little bit more, but I think it'll fit. So my real roadmap will then be miles per minute, and it sounds like from miles I want to go to feet, still per minute, and then inches, still per minute, centimeters, still per minute, let's see, where are we here, centimeters, and we want to go to meters, still per minute, and just enough space, meters per second. And again, that's exactly what I want to see. I recognize there's a pathway for each of these individual arrows. That gets me to my final answer. Okay, then what we want to do, and I'll come back over here, is we're going to show our solution. And now we're going to start with whatever they give us. And so it's not listed as a speed, it's just information as speed. It's totally okay. So I have 1 mile per 18 minutes. To convert miles to feet, I'm going to put the mile in the denominator, the 5,280 feet in the numerator. I need to go to feet from feet to inches, so I have 1 foot is 12 inches. Inches to centimeters, 1 inch is 2.54 centimeters. Centimeters to meters, 100 centimeters is 1 meter. And at this point I've got the numerator units. Now I need to get the minutes to go to seconds. So I have that 1 minute on top is going to be 60 seconds down below. And at this point we want to cancel all our units out. My red pen that doesn't work. What? Oh, there it is. So my miles cancel, my feet cancel, my inches cancel, my centimeters cancel, and I'm left with meters. And then my minutes cancel here, my minutes cancel there, I'm left with seconds. And so I see then that this is going to be equal to some number of meters per second. Okay, the actual calculation is trivial. The only thing that I'd encourage here is not to separately calculate a numerator and a denominator, but rather just keep a running calculation going for the whole thing. So quite literally, I would enter 1 divided by 18 times 5,280 times 12 times 2.54 divided by 100 divided by 60 equals, and I get 1.49. And if possible, I like to sort of ask myself if that's a reasonable number. So consider walking speed. If we trust that you can do a mile in 18 minutes, which is doable, that's walking speed. Then the question is, well, if you were walking across the room, how long does it take to go 1.5 meters? Call it 5 feet. Can you walk 5 feet in a second? Yeah, that sounds a little quick, but it's certainly in the right order of magnitude. So to me, the important thing is the units worked. I was kind of careful with the placement of the conversion factors and whatnot, so I'm comfortable with that. And then that icing on the cake is that is a reasonable final answer. Okay, so again, there's one that's about speeds. The next problem, having to do with the avocados in Mexico, I used to love their jingle. Anyway, is straight out of the book, and this one uses what we might call ad hoc conversion factors, where they're telling us something. It's not a constant that would be looked up in a textbook, the 18 pesos to the dollar, but rather something we might have to check the newspaper if we wanted to know exactly what it was on any given day. Newspaper, how about the internet? Okay, so one more time, I'll put up my pause light. Pause. So if you have not yet worked that one out, do it. Create a roadmap and then a solution, and then come back and watch the rest of it and see how we do. All right, here we go. So for this one, again, that first step is, well, what are we actually trying to find here? So in Mexico, blah, 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 what is the cost in cents of an avocado? So that's what we're trying to find, cost of an avocado. And the units are wanted to be in cents. Okay, so that's our end, our final, and our starting point. A couple of places we could go, but I'd probably say that I'm starting with either one avocado or or the weight of the avocado. And again, I probably am actually going to start with one avocado and then say an avocado weighs 0.45 pounds. But this starting point, you got a little flexibility on there because there's a one, single avocado. All right, so my roadmap then, see if we can get this right on the first try, is going to be avocados to pounds. Let's see, from pounds, what are we going to do? Well, we've got a mass here, and our conversion from sort of money to mass is this peso to kilogram thing. So I'm going to probably want to go from pounds to kilograms. Now on my units up here, I didn't really have that, did I? Let's see, pounds per kilogram. I got a pound in grams and grams to kilograms. So I might need to do that in 2 steps, depends on my comfort level there. But we'll say this is going to go from pounds to grams, and then from grams to kilogram. And again, with a little practice, we could probably just do that in a single step. All right, from kilograms, we're going to go to pesos. The symbol for a peso is dollar, or peso, I guess. But we're going to call that peso MXN, or dollar MXN. And then we're going to go to dollars US, and then cents. Okay, so usually when I do this, I cheat and I call the peso just a capital P, but apparently that's true in the Philippines, not actually in Mexico. All right, so is that going to work for us? Well, it's an unusual dimensional analysis problem, but that's exactly what we want to be able to do, sort of apply this to anything just on the fly. Okay, so I will say that I'm starting with 1 avo. Here's my solution. 1 avo. And I have that 1 avo is that 0.45 pounds, wherever we set it, 0.45 pounds. And again, I could have ignored the avo and just started with 0.45 pounds. And as long as I was comfortable with having done that, I'll still get the same answer. Okay, 0.45 pounds, I need to go ultimately to kilograms, so I have that 1 pound is 454 grams, and that 1,000 grams is 1 kilogram. So that gives me kilograms. Then I have that 1 kilogram of avocados from Mexico is, what do we say, 48 pesos. MXN. I've got to give myself a little more space on these. And then to go from the Mexican, the conversion factor is given that there's 18 pesos in $1. And of course, in $1, there is 100 cents. All right. Oops, give myself a little more breathing room here. Do the units cancel? We hope so. Well, our avos was sort of trivial, so that cancels. Pounds cancels. Grams cancels. Kilograms cancel. The Mexican peso cancels. The US dollar cancels. I'm left with cents. So it looks pretty good. And again, with the calculation here, if we can just run it, just use the calculator as it's designed for, but do that calculation as a running total sum. So I'm going to have 1 avocado, if I want to do that, but 0.45 times 454 divided by 1,000. Anyway, my times 48 divided by 18. So that's 0.54, and then multiply by 100, and I get 54.48 cents. So I'm not sure how sig figs would really work here with those conversions, but we'll say there it is, 54 cents. Now if you shop for avocados, even at Costco, they're like $1.50 now, so it's a pretty good deal if you can afford the gas. Plus they're better, straight off the tree. Okay, so with both of these problems, you know, the sort of intermediate difficulty, we'll see things that are a little more abstract as we move along. We'll deal with things that are volumes and, you know, fancier dimensions that there's some tricks to pay for. But this is the kind of stuff we want to be able to do probably right now. And again, the important thing, in my view, is either that first or second step, you know, identifying what it is we're trying to do, but the roadmap. The roadmap is important. Because if you can make a roadmap, you can do the solution easy. But if you can't sort out a roadmap, you don't have a strategy, then it's sort of a grasping at straws, just sort of shaking things around and hoping something fits. So you want to design a solution using a roadmap. All right, I hope that's helpful. Ooh, 20 minutes.